Do you know that our buildings consume approximately 40% of all energy produced in the United States? There is a general effort to reduce this wasteful consumption by the building sector, driven by the federal government and some commercial organization. The suggested solution is net zero energy buildings. A net zero energy building is simply a building in which energy used over the course of the year is offset by renewable energy production. A net zero energy building in its purest form would be an agricultural barn that doesn't use any energy at all. Each net zero building is a combination of efficient design and renewable energy generation. First, energy efficiency is achieved by reducing energy loads, optimizing building design for passive strategies, and recovering waste energy. Second, energy is produced on site from renewable resources such as solar and wind power. Not only net zero buildings are good for the environment, but they also can reduce your utility cost to zero. Why then do we see so few of them? There is a common misconception that such buildings have higher initial cost. Let's learn more about net zero buildings. Each successful net zero project starts with a collaboration among building disciplines, including electrical, mechanical, plumbing engineers, architects, and energy modelers. The key factor for success is to get all team members on board in their commitment to achieve high energy performance. Net zero project feasibility depends on climate, location, and available resources. It's easier to achieve net zero buildings in a mild climate of Atlanta than in super cold Anchorage. Suburban single-family houses are better candidates for net zero than high-rises downtown Chicago. Net zero feasibility is a function of building principal activity and schedule of operation. The longer its hours of operation, the more energy has to be offset by renewable energy generation. It's easier to achieve net zero in a nature center open only in summer months than in a critical facility. Different building types have different process loads. While residential buildings have minimal usage of electrical lights, kitchen gadgets, and washers, manufacturing facilities have very high process loads which can't be easily reduced. These buildings will have a hard time achieving net zero. Often when individual buildings are not qualified for net zero, neighborhoods and communities can. Diverse communities can support many technologies better and more cost-effectively, such as combined heat and power generation, load diversification, and recovering waste energy. Finally, the success of net zero buildings largely depends on people who use these buildings. If your occupants are not committed to reducing their personal energy use, then the whole net zero structure can fall apart. Educate your occupants and get them on board. Do net zero buildings look any different than conventional construction? Not really, they look the same, if not more modest. The strategies to reach net zero energy performance should be specific to the climate of your site and use passive techniques including natural ventilation, daylighting, thermal mass, and others. Net zero step 1. Reduce exterior loads as much as possible. Building shape and orientation should be optimized to reduce heat gain and loss through the envelope. Glazing area should be limited and optimized to daylighting. The resulting building should be dressed in well-insulated walls, roofs, and high-performance glazing. Net zero step 2, reduce interior loads as much as possible by using LED lights, daylight and occupancy sensors, Energy Star appliances, and low-flow plumbing fixtures. Simply switching from fluorescent lights to LED can help reduce energy by 30%. Net zero step 3, once building internal and external loads are minimized, use high-efficiency HVAC equipment with additional ECM measures such as demand control ventilation or heat recovery. Now the reduced energy needs of your buildings can be met by renewable energy resources. This can be done by installing PV arrays or wind turbines. The prerequisite to successful renewable generation on site is a good access to sunshine and strong winds. It also requires a sufficient roof and site area. Note that the net zero building is still connected to a regular power grid. Who are the best candidates for net zero? According to DOE, these are non-refrigerated warehouses, religious buildings, retail stores, and educational buildings. The least likely candidates to meet net zero would be hospitals, labs, and food service facilities. Before we conclude, let me mention a few net zero projects that the Cyclone worked on. These include a retail store, a nature center, and an elementary school. We also expand our expertise in net zero analysis by working on energy modeling competitions. An experimental 14,000 square feet Walgreens store built in Evanston uses efficient envelope materials, lighting, and a geothermal system. Its annual energy use is 57% less than a typical Walgreens store. The energy is offset by 850 solar panels on the roof. Austin Gardens Environmental Center in Oak Park is a 2,000 square feet Chicago Park District facility for children and adult education. The building uses efficient envelope, daylighting, rainwater collection, and a geothermal system. It also has 70 PV panels installed on the roof. Finally, the Academy of Global Citizenship is a 70,000 square feet exemplary elementary school with a focus on sustainability and urban farming. The building is still in design stage, but is expected to significantly reduce its energy use in comparison to a regular school building and to generate energy on site. If you want to learn more about net zero energy buildings, come talk to us. Thank you.